The hydrological cycle. What is the natural cycle of freshwater replenishment? Where is freshwater stored for our use, and how does increased global temperature affect freshwater storage? These are the questions that we'll be considering in this video. The hydrologic cycle consists of the pathways for how water moves and is distributed on the planet. Recall that we're largely focused on freshwater, so the oceanic water is not considered. Let's begin by thinking about water in the atmosphere. Our atmosphere naturally absorbs water vapor. We refer to this as humidity. The water vapor is provided by evapotranspiration from Earth's land surface and evaporation from Earth's water surface. The concentration of water vapor that can be absorbed in the atmosphere increases with increasing temperature. The term relative humidity is the percentage of water vapor in the air relative to the concentration that the air can hold when it's saturated. When the temperature drops sufficiently to cause the water concentration to exceed the saturation limit of water in air, water will do one of two things: either condense to small liquid or small ice particles, which we recognize as clouds, or precipitate out in the air. It is this precipitation of water from the atmosphere that refills our natural freshwater reservoirs. As shown in this image, precipitation can be stored directly in reservoirs such as streams, rivers, or lakes, or it can infiltrate the soil and end up in the underground aquifer. This image shows the source of various types of water. From a developed country viewpoint, the type of water treatment required for human consumption depends on whether the water is collected directly from precipitation, reclaimed, surface water, or groundwater. This image shows the approximate distribution of fresh water in various reservoirs. At the time of creating this video, our best science estimates over 2/3 of the fresh water is in the form of glaciers and permanent snow cover. Of the remaining, most is in groundwater, and 1% of the total is estimated to be in these more or less accessible forms. We'll note that the volume of glaciers is shrinking dramatically each year, as indicated by images taken by NASA. One of the issues with global warming is that the combination of warmer surface temperatures and a warmer atmosphere has the effect of drawing more water vapor into the atmosphere, shifting the storage of water from more accessible forms to less accessible forms. Fresh water is critical to all life forms, so depleting these natural reservoirs of water jeopardizes all life forms, including the life forms that create the biological services to support life. Fresh water is stored in the atmosphere through evaporation and evapotranspiration. The release of atmospheric water is regulated by temperature-sensitive processes. Global warming has the effect of increasing the water vapor solubility of the atmosphere and increasing both evapotranspiration and evaporation rates. The result is that easily accessible water is moved to the atmospheric reservoir, which is generally less accessible. Depleting the accessible water reservoirs jeopardizes all life forms and biological services which depend on water.